Hi everyone, what's up? Welcome back to my tutorial channel. It's Daniela Chuan here, and today we are going to work on section A-1, the core level from the IFM Practice. Alright, so the first problem. Consider the following one-period binomial stock price model for a non-dividend paying stock. You're given the period is 1 year. The continuously compounded risk-free interest rate is 0.02. Consider a 1-year 100 tri-European call on the stock. Construct a replicating portfolio and calculate the time zero price of the call option. And here we are given that current stock price is 100 from the diagram. And a year later, the stock price can be either 105 or 95. So we need to first construct a replicating portfolio and then calculate the time zero price of the call option. Basically, constructing a replicating portfolio here means determine the numbers of the bond, the amount of money we invest in the bond, and the number of the share of the stocks. Here, before we construct a replicating portfolio, let's calculate some important numbers. Here, S of 0 is 100. There's a current stock price. SU is the stock price, the upper stock price. Here, the stock price can be either 0.05 or 95. 105 is the higher value, so this is SU, and SD is 95. SU is S0 times with 1.05 right here. So actually 1.05 here is U. Similar, SD is 95 and it is equal to S0 times 0.95 because S0 is 100. So D here is 0.95. The CU is the payoff of the call option in case that the stock price goes up to SU. So it's equal to SU minus K plus, because this is a call option. We got SU is 105, K is 100. So 105 minus 105 a positive number, so CU is 5. Now CD, we take SD. SD is 95, subtract the tri of 100, we got negative 5. And we flip to the positive number, so it should be 0 because negative 5 is less than 0. Let's delta be the number of shares of stock and be the amount of dollars in bond. So the current stock price, the current price of the call option should be C0 is equal to delta times S0 plus B, because we have delta number of shares of stock and the current price of stock is S0, and let's say B is the amount of dollars in bond. So the total cost at this time to construct this call option is delta S naught plus B. So in order to calculate C0, we have to determine delta and B. Here, let's consider this case. For the case when the stock price goes up to SU, we got the CU should be equal to first the number of stock share times with the e to the delta H, because the dividend use is delta. So after H years, we got the number of stock shares should go up to delta times e to the delta H. And the price of each share of stock is SU at that moment, so we have to time with the price. And B is the amount of dollars in bond at time 0. And it's accumulated to B times e to the RH at time H. Here H is 1 because we consider 1 year. Delta is equal to 0 because this is a non-dividend paying stock. R is 0.02. And CU is calculated as 5 from the above step. So we got phi is equal to 105 delta plus B e to 0.02. And similar for CD. CD is a pair price of the call option in case the stock price falls down to 95. So in case the stock price falls down to 95 at time H, we got delta times e to the delta H, number of shares of stock, where the price of the stock is SD. So we got delta e to the delta H times SD. And the B amount of dollars in bond at time 0 is B, will be accumulated to B times e to the RH at time H. That's why we got CD is equal to delta e to the delta H SD plus B e to the RH. CD is 0. So 0 is equal to 95 delta plus B e to the 0.02. Now we have a linear system of two variables. We want to solve for delta and B. This is a very easy system. Here for me, I subtract side by side to cancel out the term B e to the 0.02 and withdraw 10 delta. 10 delta is equal to 5, so delta is 0.5. And use delta to calculate B. We got B is negative 46.5594. So now we have constructed the replicating portfolio. In this portfolio, we have 0.5 shares of stock, and we have 46 $55.94, negative 46 $55.94 in the bond amount. So the time 0 price of the call option should be C0 is equal to delta S0 plus B. So C0 is 0.5 times 100 minus 46.5594. We got C0 is 3.44. That's the answer. Problem 2. For a non-dividend paying stock you are given, the current stock price is 15. The stock price after 1 year can be either 20 or 10. Hang calculates the no arbitrary price of a European at the money put on the stock using an annual effective interest rate of 10%. Hang's price is denoted by PR. Norma believes that the annual effective interest rate should be 20%. She calculates the no arbitrary price of the same put based on the rate of 20%. Norma's price is denoted by P2R. Calculate PR minus P2R. Again, let's summarize the question. Here the current stock price S0 is 15. After a year, the stock price can be either SU or SD. SU is 20 and SD is 10. The CU, the payoff of the call option, can be either 5 or 0. Here it said the at the money put, meaning the try should be the try should be the same with the current stock price 15. Alright, and here we calculate the risk neutral probability. We got P star is equal to S0 times 1 plus R minus SD over SU minus SD. This is from the formula, and this is equal to either 0.65 or 0.8 depending on the risk-free interest rate, whether it's 10% or 20%. We got PR here is CU 1 minus P star over 1 plus R, which is 1.59, and P2R is CU 1 minus P star over 1 plus R in case R is 20%, and it is 0.83. So PR subtract P2R is where the absolute value should be 0.76, and that's the answer. Which of the following statements is true with respect to pricing a derivative? A. The expected payoff is calculated using the risk neutral probabilities. The price is equal to the present value of expected payoff discounted using the risk-free interest rate. B. The expected payoff is calculated using the risk neutral probabilities. The price is equal to the present value of the expected payoff discounted using the derivative rate of return. The expected payoff is calculated using the true probabilities. The price is equal to the present value of expected payoff discounted using the risk-free interest rate. D. The expected payoff is calculated using the true probabilities. The price is equal to the present value of expected payoff discounted using the expected rate of return of the underlying asset. E. None of the above is true. So by the definition, we have the expected payoff is calculated using the risk neutral probability, and the price is equal to the present value of the expected payoff discounted using the risk-free interest rate. And the correct answer here is A. This is right at the definition of the risk neutral probabilities. So A. The expected payoff is calculated using the risk neutral probabilities. The price is equal to the present value of expected payoff discounted using the risk-free interest rate. Problem 4. You are given the following regarding stock of which is worldwide WWW. The stock is currently sold for 50. 1 year from now, the stock can be either 40 or 50. The stock pays dividends continuously at a rate proportional to its price. The dividend yield is 10%. The continuously risk-free interest rate is 5%. Given the trial is 50, calculate the time zero price of the call option. So whenever you want to calculate the time zero price of the call option, you either can use the risk neutral probabilities or set up the replicating portfolio. There are two ways to go to come up to the time zero price of option. Here, let's summarize the question. S0 is 50 because the current stock price. The stock price after a year can be either 40 or 50. So 40 is SD and 50 is HU. SU is 50, S0 is 50, SU is 55, S0 is 50, so U is 1.1, and of course D is 0.8. CU is 5 and C0 is 0. Let delta be the number of shares of stock and B be the amount of dollars in bond. So C0 is delta S0 plus B. As I said, there are two ways to go to S0, either construct a replicating portfolio or calculate it through the risk neutral probabilities. Here I use the first method, replicating portfolio. I got a linear system of two variables. I have CU is CU here is the upper price after a year. It is equal to delta e to the delta x times SU plus b times e to the RH. Because let's say at time 0 we have delta number of share of stock. So after x year, we will have delta e to the delta h number of share of stock because we have dividend continuously wrote. And SU is the price of the stock at the time h. And B is the amount of dollars at time 0. So it's accumulated to B times e to the RH at time h, with R is the risk-free interest rate. Similar for CD, we got CD is delta e to the delta h at D plus B e to the RH. And from here to plug the number in, we got 5 is 55 e to the 0.1 delta plus B e to the 0.05. 0 is equal to 40 e to the 0.1 delta plus B times e to the 0.05. And from here, we solve for delta and B. We got delta 8.3 and B is negative 12.6831. Hence, the time 0 price of the call option is 2.4 because C0 is delta times S0 plus B, where delta is 0.3016 and B is negative 12.6831. S0 is given at 50, so C0 is 2.40. Problem 5. For a 1-year straddle on a non-dividend paying stock you are given, the straddle can be either exercised at the end of the 1 year. The payoff of the straddle is the absolute value of the difference between the strike price and the stock price at the expiration date. The stock currently sells for 60. In 1 year, the stock will either sell for 70 or 45. The option has a strike price of 50. The continuous risk-free interest rate is 8%. Calculate the risk-neutral probability and the price of the straddle. So, for this case, I'm going to use the second method, the risk-neutral probability, because the question also asks for it. But let's summarize the question. At 0 is 60, the current stock price. At D is the lower stock price after a year, 45. At U is 70, of course. And here for the straddle is set up that the payoff of the straddle should be the absolute value, not the regular way to calculate the payoff. So we got CU is absolute value of 70 minus 50, which is 20. Remember, for the old methods, we take 70, subtract 50. If it's positive, we take it. If it's negative, we turn to 0. But in this case, we find the absolute value. CD is 45 minus 50, absolute value. It should be 5, not 0. U is SU over S naught, which is 70 over 60, 76. D is at D over 6 S naught, which is 3/4. The risk-neutral probability B star is 0.8. And the price of the straddle is C0 is equal to E to the minus RH times B star CU plus 1 minus B star CD, which is E to the negative 0.08 times 0.8 times 20 plus 0.2 times 5. We got 15.7. Alright, so that's it for today. Thanks so much for watching. I hope you guys enjoyed my video. Please like, share, subscribe. See you in the next video.